Right. So can any of you tell me where we experience friction, like some situations where we experience friction in daily life?
We're almost every.
Almost everywhere. Okay, fine. Tell me some ways in which it helps us.
So walking.
Like road.
Definitely. Yeah. Any surface, if you want to walk or drive on it. Yeah, friction helps us with that. Next, any other examples? It
So
helps
to
us
place
only
an
with
object on surface.
just see, many things around you, they stay in place because of friction. Had friction not been there, they would have been sliding. Okay, because surfaces are usually not perfectly horizontal, right? So generally many like maybe the chair, the table, okay, the laptop or the phone that you are using, they're all held in place with the help of friction. It is one of the forces which is helping them stay there, right? Okay, fine. Now see, we had discussed about three forces before. One is the weight of an object. Weight is basically the gravitational force that an object experiences from the earth. Then we discussed and we even solved problems based on normal force. Can one of you tell me when normal force acts between two objects or surfaces? Where do we observe normal force to be acting?
They are pressing each other, sir.
When one object pushes another object or presses onto another object, normal force arises between them. Correct. So basically, normal force is a pushing force of contact. Then we even talked about tension. Tension is a pulling force, right? So when an object tends to get stretched, tension will get developed inside it. When an object tends to get compressed, it will exert normal force. When it tends to get stretched, tension arises inside the object. Okay, fine. Now, if you have any idea, you tell me, when does friction act between two surfaces? Let's take an example. Just a moment. You all think about it. When does friction act between two surfaces is my question. Yeah.
So when one body goes against the other body in an opposite direction.
Okay, it's like when one object rubs against another
Yes, sir.
object, you are saying. Okay, that's correct. Basically, when one surface rubs or slides against another. Okay. That makes sense. But is it compulsory that the object rubs or slides against another surface for friction to act? Consider this situation, all of you. So a block is placed on a surface. Okay, on the ground it is placed. It is placed there and left. Fine. Now imagine this as a real situation. So the ground is a rough surface now. Okay, till now we had considered smooth surfaces. Now from now on we'll consider rough surfaces as well. So we kept a block there and released it. Can one of you tell me what all forces act on the block? Medha, you tell me, what forces do you think act on the block? Like, as of now, the forces we are considering are these: weight of an object, normal force, tension, and from now onwards, we'll start talking about friction also. If you think friction acts, you can tell. So out of these forces, which forces do you think act on the block? Okay, anyone who wants to answer my question?
Normal and gravitational force.
Okay, Earth's gravity will be acting on it. That is the weight of the block will definitely be acting on it. And as we all know, weight will be acting vertically downward. Okay. Fine. Along with weight or due to weight, the block tends to press the surface or press the ground in the downward direction. Okay. So that will generate a normal force from the ground. It will act like this. Okay. Why does normal force act like that? Because it has to prevent the object from going down into the earth. So it acts in the upward direction. That's fine. Normal force. The block is not being pulled by anything, so there will not be a tension acting on it. If an object is pulled by any force or any rope or a rod, then you have to consider tension acting on it. In this case, it will not be there. But now it's on a rough surface. Tell me, will friction act on this block? If yes, in which direction will it act? Just from your everyday experience, whatever you feel, you can tell.
Sir, what was your question?
Will friction be acting on the block? If yes, in which direction will it be acting?
Sir, yes.
Okay, can you guess the direction in which it acts?
Sir, in both directions.
Huh? Both directions,
Okay.
which way, right and left.
One direction, sir.
So you are saying it will act both to the right and to the left.
Yes, sir. అప్పుడే స్టేబుల్ గా ఉంటుంది.
Even if even if friction doesn't act, it is stable only, no? How can you tell that it will act and it will act both ways?
Sir, I don't think there will be any friction acting on because it's not in motion or anything, right?
Okay.
So I think
We'll
there is
see.
friction.
Huh.
So I think it's in all directions, or that the contact point.
How do you say there is friction acting and in all directions? See, these are good points that you're coming up with, but can you justify your answer? Why should friction be acting in the first place? Some of you are saying no friction. Some of you are saying friction acts in many directions. Okay. Aishwarya, what do you say? Do you think friction will be acting in this case? If yes, which way?
Sir, I think friction will act, but I have no idea.
Okay. Okay. Punyata, any answer?
Sir, I'm not sure.
Okay, fine. No problem. Now, see, I'm sure you all have experienced friction. If you haven't, you can try it now itself. Just place your palm on the table and try to slide your palm. Okay. You will feel an opposition to the sliding. That is what we call friction. That force is what we call friction. So some of you think there will be no friction acting. Some of you think friction acts and are not able to tell in which direction it acts. Okay. So see, we know weight is gravitational force. The gravitational force exerted by Earth on an object. Okay. Two masses automatically exert gravitational force. It happens like that in nature. So that is what gives rise to weight of an object. Normal force is when one surface pushes or presses against another surface. Tension is when anything gets pulled. Okay. Tell me, when does friction act between two surfaces? One of you said when the surfaces are sliding. Now here the block is placed at rest. It's not sliding. So does that mean there should be no friction acting on it? Or generally, not just in the case of this block, generally, when does friction act between two surfaces and what gives rise to friction? Just share your opinions. Okay.
Sir, you said friction holds object in place, so I think friction does exist.
Okay, since the block is found to be in place, you're saying friction friction must have been acting on it. Okay, okay.
So when an object moves, then friction will act opposite to the motion of the object.
Okay, you're saying whenever an object moves, friction acts opposite to the motion of the object. And this is also a very interesting point. Actually, we are going to discuss this in detail. So friction I'll denote with small f, acts opposite to the direction of motion of the object. Okay, that is one idea. We'll see. Like you all try this, just place your palm on the table. Don't try to slide your palm or anything. Just place it on the table. Do you see or do you feel any force acting on your palm parallel to the table? Of course, perpendicular to the table, there will be a force acting. Like if you place anything on a surface, perpendicular to the surface, normal force will be acting. But parallel to the table, do you feel your palm being acted upon by any force when you just place it there? If yes, in which direction do you feel your palm is being pushed or pulled? That also you'll have to tell. Saket,
No
have you?
force is acting.
Okay, Pawan is saying he doesn't feel any force. Okay. Saket, what do you say? When you just place your palm on a surface, on the table surface, are you feeling any force along the table surface?
Yes, sir.
Which way is your palm getting pushed or pulled?
In the perpendicular direction.
Perpendicular direction. Okay. See, perpendicular doesn't count as along the table. Okay. For example, not for example, you understand this. Suppose this is the table surface. A force acting parallel to the table is called force along the table. Okay. A force acting perpendicular to the table is not a force along the table. This normal force, yes, we can all feel it. Okay. Do you feel any force acting parallel to the table? That's my question.
No, sir.
Okay. Your palm is a rough surface, I'm sure. The table also must have been a rough surface. Anyway, like different tables have different levels of roughness, but some roughness will definitely be there. Okay. So your palm, when it is in contact with the table, it's like two surfaces are in contact. But some of you are saying there is no force acting parallel to the surface. Friction is a contact force which acts parallel to the surface. Now you said you don't feel any force parallel to the table, which means you don't feel any friction. Even though they are rough surfaces, you don't feel any friction. And that is correct. Okay. When your palm is simply placed on the table, okay, there won't be any friction acting on it. But now you all try this. Try to slide your palm, like place it on the table and slide your palm away from your body. Okay. Then do you feel any opposition to that sliding or not? You place your palm on the table and slide your palm away from your body. Do you feel any opposition to that sliding or not?
Yes, sir.
Okay. In which direction is that opposing force?
So against the direction of my hand.
Against the direction in which you are sliding your palm. Correct. If you slide it away from your body, you will feel the opposing force towards your body. Or if you slide your palm to the right, okay, you'll feel the opposing force acting to the left. Right. So this helps us understand something about friction. Friction is a force which tries to prevent, okay, keep this point in mind, all of you. Friction tries, it's not always successful in doing it, but it tries to prevent sliding between two surfaces. Okay, so this is a very important statement. The meaning of this statement is important. Friction tries to prevent sliding between two surfaces. It implies that if two surfaces which are in contact, of course, they have to be in contact. If two surfaces which are in contact have no tendency to slide against each other. Okay, if they don't tend to slide against each other, then friction will not act between them. Even if it's a rough surface, friction will not act. So keep this point in mind. Friction is a force which tries to prevent sliding between two surfaces in contact. Okay. Is this clear to all of you? Do you all agree with this or not? Now you think of some situations where you felt friction must have been acting, and see for yourself or think for yourself if this is true or not. Anywhere you feel friction is acting, just check, is it trying to prevent sliding or not? For example, I'm able to hold this pen by means of friction itself. Had friction not been there, I would not have been able to hold this pen. It would have slipped off like this. Okay. So what is friction doing here? It is preventing sliding between the pen's surface and my finger. Okay, because had friction not been there, or had this been a very oily pen, slippery pen, it would have fallen off like this due to gravity. Friction is preventing that sliding. Okay. So I want you all to think about it for a minute. And if you are not convinced that friction prevents sliding, you can let me know. Okay. So any objections, any doubts, anyone? Okay, let us come back to this question. Here, the block was placed on a horizontal surface. It was gently placed there and released. Now, whether you like it or not, gravity is definitely going to act on the block. Okay, Earth's gravity will definitely act on it. It will try to pull the block down, as a result of which the block presses the ground. So a normal force gets generated. These two cannot be avoided. They will be there. They will act. Okay. But now you all think about it. Weight and normal force on the block, in which direction are they acting? Vertical, horizontal, or partly vertical, partly horizontal? They have components both ways. What do you think? Rishi, what do you say? Weight and normal force in this case, are they vertical? Are they horizontal? Or do they have components both in vertical and horizontal directions?
Sir, it's vertical, sir. It's
They
only
are both,
vertical.
it's obvious, they are both vertical.
Yeah.
Okay. Upward, downward are vertical directions. Will they have any horizontal components?
No, sir.
No. Okay. Generally, any vector whose magnitude is a and makes an angle theta with some direction, its component in that direction would be a cos theta. Here, normal and weight, they are vertical, means they make 90 degrees with the horizontal. If the angle is 90 degrees, cos 90 becomes 0. They have no component in the horizontal direction. Okay. Vertically, these two are balanced. That's fine. Horizontally, there is nothing trying to disturb the block. Then you all tell me, if the block has been released at rest, okay, it was gently placed there and released at rest, will it have a tendency to slide horizontally in the absence of friction? Is there any other force to make it slide horizontally? Vanilla, what do you think? Is there anything trying to make the block slide horizontally?
No, sir.
No. Okay, I hope others are also convinced with this. There is no force at all in the horizontal direction. Now tell me, does the block have a tendency to slide on the surface?
No, sir.
No, there's no reason why it should slide. There's no force making it slide. And initially it was not sliding. Why will it start sliding when there's no force? It won't. Okay. So in this case, there is no tendency to slide. It means there is no need for friction to act. Friction only tries to prevent sliding between surfaces. If on their own they have no tendency to slide, then friction has nothing to do there. Even if the surfaces are rough, friction won't act. Okay, so the correct answer to this question is that there will be no friction acting, because there's no need for it to act. Okay, so remember, friction arises when necessary. What is the necessity? Preventing sliding is the necessity. So what I just explained is the most important part of friction. When you solve problems involving rough surfaces, you have to imagine the situation on a smooth surface first. Okay, ignore the roughness of the surface, imagine it is smooth. Visualize what would happen if the surface is smooth. Okay, if the surface is smooth, suppose the blocks have a tendency to slide, then friction will come into play. If the surface is smooth and the blocks still don't have a tendency to slide, then even if friction is available, it won't act. Okay, even if it's a rough surface, friction will not act. So remember, friction tries to prevent sliding between two surfaces. So you need to check if two surfaces have a tendency to slide in the absence of friction. In the absence of friction itself, if they don't tend to slide, then definitely there's no need for friction to act. Okay, and one of you was saying friction acts opposite to the direction of motion. Think about this, all of you. Think of several situations where friction acts. Okay? And tell me how friction is acting opposite to the direction of motion. I'll give you 1 minute. I'll ask you for examples how you think friction acts opposite to the direction of motion. Okay. Okay. Pawan, do you agree with this statement?
Yes, sir.
Okay. Can you give me an example where you can observe this?
Sir, bike.
Bike. Describe what is happening to the bike.
సార్ బైక్ ఇప్పుడు సపోజ్ రోడ్ మీద వెళ్తున్నప్పుడు అంటే స్పీడ్ స్లోగా గెయిన్ అవుతుంది సార్, అంటే ఫ్రిక్షన్ కి అంటే ఎక్కువ అయినప్పుడు ఫోర్స్ అనేది.
So what you are saying is, if friction is high, the bike will not be able to speed up quickly. Is that
Yes,
what you
sir.
are saying? Okay. Okay. We'll discuss this. Bike speeds up slowly because of high friction, or in the presence of high friction. Okay, let's see. Sagar, do you agree with that statement that friction acts opposite to the direction of motion?
Yes, sir, I do agree.
Give an example.
Sir, running, sir.
Running. Okay. So fine. If a person is running forward, you say friction will be acting backward.
Yes, sir.
Okay. Medha, can you comment on this? Do you think friction acts opposite to the direction of motion or not?
Sir, I think it does.
Okay. Can you give any situation or example where you can feel it happening?
I'm not sure.
Okay, fine, fine. Vanilla, you are the one who said friction acts opposite to the direction of motion. Give an example.
Sir, when an object slides down an inclined plane, friction
Okay.
acts oppositely.
Fine. Object slides down an incline. Friction acts Up the incline. Okay, makes sense. Rishi, what do you say? Is it true that friction acts opposite to the direction of motion always?
Yes, sir, it does.
Example?
Sir, the hand sliding on the table after a
Okay.
point, it's
Fine. Yeah. When you slide your palm forward, you can feel friction acting backward. So there, friction acts opposite to the direction of motion. Okay. So, okay, I have a question for all of you. Just a moment. Suppose there is a horizontal surface, ground itself. Okay, just 1 second. Some rough surface you imagine. Let's say there's a person standing on it. Okay. 1 second. Assume this is to assume the rightward direction is east. Okay. So, see, understand the question properly. Person was simply standing there. Okay. Person initially at rest starts walking towards east. Okay, when you start walking, this is what you do. One foot will stay on the ground. You will move the other foot forward. Okay, so he is in that process of moving his other foot forward. So he's starting to move towards the east. Remember that. Type your answers in chat. Should friction be acting on the person or not? That's the first question. When he starts walking towards east, should friction be acting on the person or not? That is one question. So answer will be yes or no. And the second question is the direction in which you think friction will be acting, towards east or towards west or some other direction. Okay, type your answers in chat, all of you. Type answers to both questions at once. Should friction act on the person? If yes, in which direction? One, two, three, four, five, six. I got 6 responses. Okay, fine. In all the responses I got, the answer to the first question was yes. We'll see. And the answer to the second question in all the responses I got was west. Yes is correct. West is wrong. Okay. This might seem surprising to, of course, it will seem surprising to all of you who said the answer is west. Friction will not act towards west. Okay. Any of you who thought it acts towards west, can you justify your answer? Why did you say friction acts to the west?
Because friction acts in the opposite direction of motion.
Okay, because you all agreed with this statement. Friction acts opposite to the direction. I don't agree with this statement. Okay, let me tell you my answer also. This is not always correct. Okay, and you will understand why it is not always correct. See, friction does not have to prevent motion. That is not friction's job. I mean, that is not what friction seems to be doing if you observe carefully. Now you all answer this. Forget about what all we have discussed. Common sense. You all have the opinion that friction prevents motion. Friction acts opposite to motion. Now, suppose a person is simply standing and the person starts to walk. Tell me, would walking be possible without friction? Aishwarya, what do you say? Would walking be possible without friction?
No, sir.
Huh. I hope you all agree with that. If any of you thinks walking is possible without friction, let me know. Okay. Then in that case, if you feel friction is necessary to walk, is friction helping in motion or friction opposing motion? If friction is what is helping you walk forward, is friction helping you move or is friction opposing your motion? Unmute and tell, like, what do you think? Is friction helping in motion there or opposing the motion there?
There it's helping
The
in the
helping motion.
It's helping. Okay. Take a simple example like this. Suppose I hold my mobile phone on my palm. Okay. It is at rest. Now, see, it's just resting on my palm, right? The forces acting on it would be normal force upward and its weight downward. Now, if I move my palm this way, the phone moves along with it. Okay. I am not exerting a separate force on the phone. I'm just moving my palm to the side. The phone happens to be moving along with it. What force is helping the phone move along with my palm? It's definitely not normal force or gravity because they are vertical forces. What horizontal force accelerated the phone? Can one of you tell? What is helping the phone move along with my palm? Is it not friction?
Frictional force.
friction only.
So is friction causing motion here, causing motion of the phone here, or is it opposing motion of the phone?
Causing it.
It is causing, right? So it is not true that friction opposes the motion of objects. Sometimes it happens, okay, but not always. What friction does is it prevents sliding. Now, understand how that is happening in this case, in the case of phone placed on my palm. See, had there been no friction between the phone and my palm, what would have happened is, like in this case, if I have to help you imagine what happens without friction, I'll have to hold the phone because I can't simply remove friction from my palm. No, it is there. Had friction not been there, okay, you all tell me, had friction not been there and I move my palm to the right, what would have happened to the phone? Would it still move or would it stay there itself and my palm would have gone to the right and then the phone falls off like this? In the absence of friction, what would have happened?
So it would have fallen down.
Till my hand goes away, till my palm goes away, it would have stayed there and then it would have fallen down like this. Because had friction been absent here, there would be no force acting on the phone horizontally. Then why will it move horizontally? It will stay there itself. My palm, I am moving it, my muscles are connected to it, so it can be moved. The phone moves only due to friction. Had friction not been there, it would have stayed there. Now see, if the phone stays here itself and my palm moves to the right, is there sliding between the surfaces or not? It is there. That is when friction comes into play. That is what friction prevents. Okay. In the absence of friction, if I try to move my palm to the side, there would have been sliding between these two surfaces. Friction hates sliding. Okay. It tries its best to prevent sliding. And what is friction doing to prevent sliding? It is making the phone go along with my hand. You don't slide against each other. If you want, you go, but go together, don't slide. Okay? So remember, friction hates sliding between surfaces. Okay. And here it is what makes the phone move along with my palm. So keep this point in mind, all of you, and we'll discuss that walking case now. Okay, if you want, you all can try this. If you start walking towards east, which way do you push on the floor with your foot? I mean, you press it down, definitely. Your weight will be acting on the ground. That's okay. But if you want to move forward, will you try to slide your foot backward? The foot that is on the ground, will you try to slide it backward or will you try to slide it forward? To walk forward. Okay, if you want to move forward, for example, to move this way, you tend to slide your foot this way, the foot that is in contact with the ground tends to slide backward. Okay. And what does friction do? Like, what is the nature of friction? Friction hates sliding. So your muscles are trying to make your foot move backward. Means your muscles are trying to make your foot slide against the floor. Friction hates that. So what it does is it exerts a force. It acts on your foot in the forward direction. Friction acts this way. Friction on the foot acts forward because the tendency to slide is in the backward direction. Okay. So if you, not just you, if any person starts walking in a particular direction, you know that friction is what is helping them walk. Then how can you say friction is opposing motion? It is helping the motion there. Okay. In fact, you can answer this from Newton's first law and second law also. Let's apply second law. Can one of you tell me the mathematical form of Newton's second law? What is the equation we write?
F net is equal to ma.
F net equal to ma, correct. It's a vector equation or a scalar equation? Is it a vector equation or scalar? Like force and acceleration, are they vectors or not? Any of you can
Vectors, sir.
unmute and tell. They are vectors. Okay. In whichever direction there is net force, in the same direction there will be acceleration. Now see, this person was initially at rest and the person starts moving towards east, means gains velocity towards east. If the person is gaining velocity towards east, it means the person is accelerating that way. Obviously, in whichever direction there is acceleration, in that direction the object will gain velocity. Okay, this person is starting to gain velocity towards east, means the acceleration is towards east. Now if acceleration is towards east, then the net force also should be towards east itself. And what is the only force, only horizontal force acting on this person? Friction. Normal force, gravity, they are vertical, they can't help in horizontal motion. Okay, only force acting horizontally is friction. Then that must have acted towards east. That is why the person is accelerating towards east. Okay, that way also you can answer that friction acts forward, not backward. So when a person is starting to move, friction is what helps start the motion. Okay, so friction acts in the same direction in which the person moves, not just person, even in case of vehicle, it's the same. Okay, just a moment. You think about this, all of you. I know it is slightly counterintuitive. It is against what you all believed all this while, but this is how it happens. This is what happens. Okay. Now consider a situation somewhat like this. Suppose there is another rough surface. You imagine a vehicle on this surface now. Okay, I'll just show one wheel of the vehicle. Just a moment. Right. So imagine this wheel is part of a car. This is the front side of the car. Okay. Fine. Suppose the car is initially at rest, and let's say the driver starts the car and puts it in forward gear, like first gear, and accelerates. Tell me, when the accelerator is pressed, which way does the wheel tend to rotate? Clockwise or anti-clockwise? If the car wants to go forward, it's in first gear, not in reverse gear. So when you press
Anti-clockwise.
anti-clockwise, you are saying this way.
Yes, sir.
Which way is the car facing, right or left, according to you?
Oh, I will go clockwise.
Okay, fine. Let me make that clear. Let's say the wheel is here and driver is here. Okay, now I think it will be better. So when we put it in first gear and accelerate, the wheel tends to rotate clockwise. Do you all agree with this or not? If any of you has an objection, you can tell. Okay. Now, suppose it's a very slippery surface, perfectly smooth, or let's say there is oil or something on the ground. Okay, assume it's a marble floor and there is oil on it. If you accelerate, will the car move forward? If it's a very smooth surface, perfectly smooth surface, and you accelerate, will the car move forward? Or simply tell, can you walk on a perfectly smooth oily surface?
No, sir.
Others, what do you think? Saket, what do you say? Saket is there or not? No. Okay. Yusuf, what do you say? If the surface is perfectly smooth, oily, can you start walking on it, or can the vehicle start moving on it?
So it's a sliding.
Will it? What makes it slide?
So if it was in already motion, then it would slide.
No, it was not already in motion. It was at rest.
No, so then.
Okay. So will the wheel rotate or not when you press on the accelerator?
Yes.
Wheel will rotate, but the vehicle will not move forward. Even when you try to walk, you will slide your foot backward, but your body won't go forward. Okay. So listen, all of you, when the wheel tends to rotate, when the wheel rotates clockwise, what happens is you observe the point of the wheel which is touching the ground. Okay, let's call this point as P. If the wheel rotates clockwise, tell me in which direction does the point P move, forward or backward, due to the rotation I'm asking. Type your answers in chat. I want answers from all of you. When this wheel rotates clockwise, the point P, due to the rotation, moves forward or backward. I got 3 answers as backward, 1 as forward. We'll see. But I want answers from all of you. Think about it. Wheel rotates clockwise. What happens to the point P? Does it move forward or backward? Okay. It will move backward. Fine. You all can look at this. Okay. This is not the image of a wheel, but just consider this. Now, if I rotate the phone, okay, you consider this green part. Green part is the bottommost part, no? And to me, clockwise is this way. Okay, for you, I think clockwise will be like this. So let it be. So I'm showing it from your point of view only. If I rotate the phone clockwise, Okay, it has to be there itself, but it should rotate clockwise. So that green part, okay, from this position, when I rotate it clockwise, which way is it going, backward or forward, according to you? Pawan, what did you observe?
Sir, it moves backward.
Backward. Okay, rotation clockwise ఉన్నప్పుడు ఆ బాటమోస్ట్ పాయింట్ అనేది వెనక్కి వెళ్తుంది. So it tends to move due to clockwise rotation. The point P tends to move backward. I'm not saying the vehicle tends to move backward. The point P of the tire tends to move backward. Okay. In fact, if there is any water or loose mud on the road, it will throw mud in the backward direction also. You all must have seen that. Okay. So since the tendency to move, in fact, I should say tends to slide backward on the floor or on that ground. If the tendency to slide is in the backward direction, then what does friction do? Friction tries to prevent sliding. So friction acts in the forward direction. So if it's a rough surface, that friction which acts forward is what helps the vehicle move forward. Okay. So whether it's walking or a vehicle moving on a road, see, if the motion is starting because of friction, then friction has to be in the direction of motion. Right? That's the idea. Later on, suppose there is a runner sprinting very fast and the runner wants to come to rest. Then yes, see, if you want to come to rest, if you are running and want to come to rest, you won't push the floor in the backward direction. You will put your foot on the ground and you tend to slide it forward. Friction will act backward and you will stop. Okay. So yes, friction sometimes prevents motion, but not always. But what does friction always do? It tries to prevent sliding. Keep this point in mind, all of you. This will help you in solving problems easily. It will help you visualize the direction of friction. Okay. Right. So friction always tries to prevent sliding between surfaces in contact. Without contact, there cannot be friction. Okay. Fine. Now see, preventing sliding can happen in two situations. First situation is when two surfaces are not sliding against each other yet, but they would slide in the absence of friction, means they have a tendency to slide. Okay. So no sliding, but have a tendency to slide. In that case, friction will act. Another case in which friction acts is if two surfaces are already sliding against each other. Then also there will be friction acting if the surfaces are rough. So first case, when the objects are not sliding against each other but have a tendency to slide, the nature of friction or the name given to friction there is static friction. We call friction acting in that situation as static friction. And when surfaces are already sliding against each other, then also there will be friction preventing sliding. That kind of friction is called kinetic friction. Okay. You can feel this in daily life also. Again, see, you just try to place your palm on the table. Okay, you press hard against the table, gently try to move your palm forward, it won't move. Okay, if you are pressing your palm sufficiently hard, even if you try to move it forward a little bit, it won't move. Basically, what is happening there is the palm has a tendency to slide on the table, but friction is not allowing it to slide. That friction is called static friction. Okay, even while walking, You place your foot on the ground. You try to slide it forward. You try backward. Sorry. You try to slide your foot backward. But if the surface is rough enough, your foot won't slide back. It will stay there only. Your body will move forward. Okay. In that case, also the friction acting is called static friction. So there is a tendency to slide, but sliding has not started yet. The friction acting is called static friction. Suppose there is already sliding. Okay, in such cases, the friction acting is called kinetic friction. Like your palm itself, you place on the table and you slide it forward. While sliding, the friction you experience is called kinetic friction. Okay, there's one more type of friction also, rolling friction, that we will discuss later in a chapter called system of particles, rotational motion. Okay, for now, you only consider static friction, kinetic friction. Okay, is the idea clear to all of you? Did you understand what is static friction and what is kinetic friction? I'll ask you to give me examples. Okay, fine. So don't give me the same palm on table and walking case. One of you tell me an example of a situation where static friction is acting. Means, had the surfaces been smooth or oily, slipping would have happened. But because they are rough, slipping is not happening. Tell me some situations like that.
So like when a bike is parked on like an inclined surface.
Okay, cool. When an object is at rest on an inclined surface. Okay. Let me show you the diagram. That example is correct only. Consider a situation like this. Assume this is a rough surface. You kept a box on it and you find that it is not sliding. Okay. So it is found or it is seen that the block does not slide. It's possible. Okay. Put friction aside. Tell me what other forces act on this block in the first place. Assume this angle of inclination is theta. Aishwarya, what forces act on this block?
So gravity and normal.
Weight and normal force will be acting, correct? How do you resolve weight into components when object is on an incline?
So M1G cos theta and M1G sin theta.
Which component acts along the incline? Weight always acts vertically downwards, mg. How much is its component along the incline? Anyone? The force is mg. How much is its component along the incline is my question.
mg sin theta.
It will be mg sin theta. Okay. Those of you who are still confused, imagine a horizontal line here. If this angle is theta, okay, theta is the angle between the incline and the horizontal, right? It means this angle is theta. Fine. It means this angle is also theta. Then this becomes 90 degree minus theta. mg makes an angle 90 degree minus theta with the incline. Then its component along the incline becomes mg cos 90 minus theta, that is mg sin theta. And the component perpendicular to the incline would be mg cos theta. Okay, in the next worksheet, I'll give you more questions based on this. You should get used to this. Right. These are the weight components, and as Aishwarya correctly mentioned, there will be a normal force also acting on it because mg cos theta presses the block onto the surface. Normal force opposes that. Fine. So if you don't consider friction, these are the other forces acting on the block. In fact, since we have shown components of mg, we can ignore the original force. This is what happens. Now see, normal force is balancing mg cos theta. That's fine. But mg sin theta would be an unbalanced force in the absence of friction. And under the influence of mg sin theta, the block would slide down if the surface is smooth. Okay. So this is how you start solving problems where rough surfaces are involved. You should first imagine what happens had the surface been smooth. Now, had this surface been smooth, under the influence of mg sin theta, the block would have slid down the incline. But it is given to you in the question that it is seen that the block does not slide. That means there must be some force balancing mg sin theta. Okay, it should be acting against mg sin theta. And what force will be preventing it from sliding? Friction. Okay. And friction acts where there is contact. Contact is on the base of the block. So we usually show friction acting like this. Okay. Now we see that the block does not slide. It is at rest. It continues to be at rest. Friction has successfully prevented sliding. Now tell me, one of you, what kind of friction is this? Static friction or kinetic friction? Is it only tending to slide or has it already started sliding? It's only tending to slide. So it will be static friction. Correct. Okay. Because it was told to you that the block is not sliding. So the friction acting there must be static in nature. Okay. Suppose sliding is already happening, then that kind of friction is kinetic friction. Let us discuss static friction in detail. Let's go back to, okay, this situation. Suppose the block has just been placed there. Okay, box. Assume it's a heavy box, say some 20 kg. For some of you, this may not seem heavy, but let it be. 20 kg box is placed on a rough surface. If it is simply placed there, we have already discussed what forces act on it. Its weight will be acting. Normal force will be acting. Friction will not act even if the surface is rough because there's no tendency to slide. Okay, so friction will not act. Suppose it is observed that, first case, let's say you start pulling it with a horizontal force like this. Some additional horizontal pulling force is applied. Let's call it F. First case, when some 2 Newton horizontal force was applied, it is observed that the block does not slide. Okay, these are observations. The block does not slide. Okay, its weight is 20 kg means 200 Newton. So normal force also would be, okay, we'll discuss normal force also. So let's say this is what is observed. We pull it gently with a 2 Newton force and we see that the block does not slide. Okay, Pawan, you tell me, what force opposes weight? What force balances weight?
Sir, normal force.
Normal force balances weight. Okay. It's found that the block is not sliding. Then what force must have been balancing F?
Frictional force.
The only possibility is friction, because normal and weight are in the vertical direction. They cannot help in the horizontal direction at all. The force 2 Newton we are applying is horizontal, and we see that the block is not sliding. Means there must have been a friction of 2 Newton generated horizontally like this. Do you all agree with this or not? Or do you think there is some other force preventing the block from sliding? Okay, hope you all agree with this. It means that the friction in this case is 2 Newton to the left. Okay, what kind of friction is this? block has not started sliding. Friction has successfully prevented sliding. What kind of friction is this?
Static.
Static friction.
Static friction, correct. Okay. Next observation. Let's say the force is increased a little bit. Let's say when force is some 4 Newton, okay, we started pulling it harder, but we still find the block does not slide. This is possible, no? Suppose you are trying to move a heavy object, like maybe a cot or something, okay, a sofa set, a cot, something like that. You push it with a gentle force, you may not see it moving. You increase the force a little bit, you may still not see it moving. Okay. So when force is 4 Newton also, the block does not slide. Okay, that's the observation. What can we conclude from this? What is balancing 4 Newton now? Which force balances 4 Newton? Medha, what do you think?
Friction.
Aishwarya, what do you think? Which force balances 4 Newton now?
So friction.
Friction itself. In the previous case, when we applied 2 Newtons, friction acting was 2 Newtons. But now when we applied 4 Newtons, you all said friction is what is preventing sliding. That is correct. Okay. It is friction which is opposing the 4 Newton. Basically, friction doesn't know about 4 Newton. Friction tries to prevent sliding. To prevent sliding, we now need a 4 Newton force to act. Okay. So friction adjusts itself. Static friction adjusts itself to, must have adjusted itself to 4 Newton. Okay. There's no other explanation. No, that is only, that must have happened. Okay. Friction must have adjusted itself. Correct. Fine. So let's say this force increases step by step. We are increasing the force, and when the force applied is some, let's say 50 Newtons, the block starts to slide. See, this happens, no? You keep pushing an object. For some force, it will definitely start moving. Okay, for small forces, the sofa set may not move. But when you apply sufficient force, the sofa set or cot or whatever heavy object you're trying to slide will start sliding at some point. Okay, so let's say it is observed that when force is 50 Newton, the block starts sliding. Block or box, whatever it is. What can we conclude from this? Like, force was increased gradually, as I'm telling you. Force was increased gradually. So one of you tell me, when this force was 49 Newton, how much friction would have acted? And what would the nature of that friction have been? At 50 Newton, it's observed to start sliding. Means at 49 Newton, it was not sliding. So how much friction must have acted at that point? At that
49 Newtons.
At
49,
that moment, yeah, 49 Newton friction must have acted. Okay. So friction, static friction, keeps adjusting itself as required. As I told you, friction hates sliding. So to prevent sliding, it will try to do whatever it can do. But we do observe that objects ultimately start sliding at some point. Okay. Like in this case, when the force just touches 50 Newton, the block is found to slide. What does that tell us about static friction? When the force just becomes 50 Newton, the block is found to slide. So what does that tell us about the nature of static friction? Is it able to balance 50 Newton? Has static friction succeeded in preventing sliding when the force is 50 Newton?
No, sir.
No. That means static friction is not able to become 50 Newton. It means static friction has limits. Okay. There is a maximum value up to which it can increase itself. It can't go on increasing to any extent. Okay, and this we observe in daily life also. Like some of you may be having a laptop or whatever in front of you or the table. You try to gently tap the table, means you are applying a force on it. You will see that it won't move. For small taps, it won't move. Okay, means friction is sufficient to prevent the force that you are applying. But you get up and push the table hard, it will start sliding at some point. For some value of pushing force, it will start sliding. That means static friction gives up. Okay, that's why I always mentioned friction tries to prevent sliding. It may not always succeed. Okay, it will put its best effort. Up to whatever extent it can increase, it will increase. But if the sliding force is stronger than that, then it cannot help. Okay, so you need to understand that static friction has limits. First, static friction is self-adjusting. Then static friction has limits or has a limit up to which it can increase itself. Increase or adjust. Okay, when the sliding force is too much, static friction gives up and the object will start sliding. And once it starts sliding, kinetic friction will kick in. Okay, that's a different situation. We'll consider that again later. Now see, when we tried to slide the block to the right, friction was acting to the left. Suppose the block is initially at rest and you apply 12 Newton force to the left. Now tell me how much and in which direction the friction will be. Yusuf, what do you say? This block was found to start sliding when the pulling force is 50 Newton. So at 12 Newton, it is not sliding yet. So tell me how much friction must have been acting and in which direction. Okay, anyone? We applied 12 Newton to the left. The block is not found to be sliding. How much friction must have been acting?
12
Newton.
Newtons. Sir.
Which direction?
Towards the right.
Towards the right. So friction can adjust its direction also, not just the magnitude. So it all depends on the tendency of sliding. If object has a tendency to slide to the right, friction acts to the left, static friction. If it has a tendency to slide to the left, then static friction acts to the right. Okay, friction hates sliding. It to prevent sliding, whichever direction is necessary, it will act in that direction. Okay, tell me, what is exerting friction on the block? Anyone? What is exerting friction on the block?
Budget one.
The ground, yeah, the surface with which it is in contact with. Ground is exerting friction on the box, correct. Now every action should have an equal and opposite reaction. So now you all tell me, where is the reaction to this friction? Don't say friction itself was the reaction to this force. That is wrong. Okay, that 12 Newton force is being exerted by someone else on the box. Okay, when you try to drag a box, you will also feel pulled in the direction of the box. Okay, that action reaction is taken care of there itself. This friction is exerted by ground on the box. So tell me, where is the reaction to this force? By ground on box. So if you consider that as the action, what do you think is the reaction to it? Medha, what do you say? Okay, Pawan. All of you, just try rubbing your hands against each other. Okay, like you keep one palm stationary. Okay, palms. Keep one palm stationary, slide the other palm against it. Fine. The palm which is moving up, it will feel an opposition in the downward direction. The palm which is moving up will experience friction in the downward direction. The palm which is here itself will experience friction in the upward direction. So one palm experiences friction downwards, the other palm experiences friction upwards. Action, reaction, equal and opposite to each other. So here we are trying to slide the block to the left. So friction from the ground acts to the right on the block. At the same time, block will be exerting friction on the ground to the left. That will also be there. This is friction on ground by the block. Okay. On the block by the ground is to the right. Then on the ground by the block will be to the left. That action reaction pair will be there. Okay. So keep this in mind. If you want, you all can try also. When you drag something, when you drag one surface against another, they will both experience friction in opposite directions. Okay. So like from experience itself, from our common everyday experience, we are able to tell that static friction can adjust itself. We do see that for different values of sliding force, friction successfully prevents sliding. Means static friction must be adjusting its magnitude. It can adjust its direction as well, but it can only adjust up to a certain extent. Static friction has a limit. Let us now discuss that limit of static friction. Okay, it's called limiting friction. What is the maximum amount of static friction that can act between two surfaces? Okay. Consider this, all of you, just a moment. A rigid wooden block is placed, like these are three different situations. Okay. The block is the same, but the surface on which the block is placed is different. So let's name them as case 1, case 2, and case 3. In all these situations, you try to slide the block to the right. Initially, the block is at rest, but you are trying to slide it to the right. So one is a rocky surface, like it's polished only, rocks. The other is a muddy surface, the second one. The third one you imagine is perfectly smooth. Maybe some very smooth tiles like marbles, ceramic tiles, something like that. Okay, so case 1, 2, and 3. What I want you all to do, you type in chat, arrange 1, 2, and 3 in ascending order of horizontal force required to slide the block. So in which case do we need the least amount of force to slide the block, to start sliding the block? Next, which case, and which case requires the highest amount of sliding force? Think about it carefully. Okay, like from your everyday experience, I'm asking you to answer. Type the order in chat, all of you. I want answers from all of you. There are 6 students online now.
Sir, what are the first and second surfaces?
First, solid rocks, as you can see. How do I say? Just a smooth surface, but it is rock. Again, maybe I should not use the word smooth. Polished rock. Okay. Second one is mud. Third one is a polished tile. So I'll mention it here. Polished rock. Second case, there is mud. This is a very smooth tile. Which case requires the least amount of effort to start the block sliding, to start sliding of the block? Which case requires moderate amount of effort, and which case requires the highest amount of force to start sliding the block? Think and answer. I'll give you 1 minute. I got answers from only 2 of you till now. Okay. Fine. I got 4 answers. 3 of you saying the order is 3, 1, 2. Third case requires the least amount of effort, followed by first case, followed by second case. And one of you said 3, 2, 1. It's okay. Okay. See, there's no perfect answer to this. It depends on the extent of roughness. I'm sure you all agree with me on that. All of you felt in third case it is easiest to slide. Okay, those of you who answered. What made you think third case is easiest to slide? What factor did you matter to you? Or basically, what is the difference in the 3 cases?
Smoothness and
Smoothness.
its polish.
Correct. Smoothness of the surface or roughness of the surface. When roughness is less, or okay, let me put this mathematically. You all feel that the smooth tile will be the smoothest of all 3 surfaces. That's why you said in the third case, we'll need the least amount of effort to start sliding the block. Now see, if you want to start sliding the block, you have to overcome static friction. These are all rough surfaces. The level of roughness varies, but every real surface is a rough surface. No real surface is perfectly smooth. Okay. At the molecular level, roughness will definitely be there. Okay. So in whichever case the roughness is less, okay, or in whichever case the roughness is the least, in that case, it is easiest to slide the block. Now you are able to slide the block means you are able to overcome static friction. Okay. In the third case, you are able to overcome static friction with a small amount of force. It means the limit of static friction is less in the third case. Okay, so let me write that here. To start sliding, the force we apply, okay, let me call it F. The force we apply must be greater than or equal to the limit of static friction. Okay, because static friction will try its best to prevent sliding. Only when the effort you are putting is more than the effort put by the friction, you will be able to slide the block. Okay, so to start sliding, the force you apply should be more than limiting friction. And we see that in the third case, okay, in case 3, the force required to slide is the least, which means the limiting friction is least in that case. Okay, so this is one of the factors on which the limit of friction depends, the level of roughness of the surface. So we say that Like we can conclude that limiting friction, that's the maximum extent to which friction can adjust itself, depends on the nature of surfaces in contact. Okay, nature means level of roughness. Okay, so that is one factor on which it depends. Okay, now consider a situation like this. Just a moment. Yeah, consider two cases like this now. They are two different blocks. Let's say one of them is a 10 kg block. The other is a 20 kg block. They are both made of the same wood. They are both on the same rock surface, polished rock surface. So now the nature of surface is the same in both cases. Now you all tell me, in which case will you need to put more effort to start sliding the block? First case or second case? You can just unmute and tell. In which case do we need more effort to start sliding the block on the surface?
For the second case.
Okay. Do you all agree with this? Any objection?
Second case, sir.
Second case. Okay. Second case requires more effort. Okay. Now the roughness is same in both cases. What is the difference then?
For the limiting friction.
See, we are discussing factors on which limiting friction depends. So due to which factor the limiting friction became more in the second case? That is my question. So let me just summarize that first here. Case 2 requires more force to start sliding the block. That means limiting friction is greater. Okay, friction can adjust itself to a greater extent in the second case. Why? What is the difference between the first case and the second case?
The mass of object.
Mass of object. At the when you look at the picture, the obvious difference is the mass. Yeah, mass of object seems to be a factor. Any other answers, anyone? Okay, now you all try this. Okay, same. Our palms will teach us best about friction. Press your palms against each other. Press them gently. Okay, press them gently against each other and try to slide. You'll be able to slide your palms relatively easily. Okay, if they are just barely touching each other, barely pressing each other, you can easily slide your palms against each other. But now press your palms very hard against each other and then you try to slide them. Tell me, when the palms are pressed harder, is it easier to slide than the first case or harder to slide?
Harder.
Do you all agree with that or not? When the palms are barely touching each other, it is easy to slide them against each other. But when they are pressed very hard against each other, it becomes difficult to slide them. Now the mass of your palms is not changing, no? Left palm, right palm, whether you just barely touch them or press them very hard against each other, the mass does not change. What is changing? Think about this carefully and answer. When palms are barely touching each other and when palms are pressing hard against each other, what has changed?
Third, the force which we connect, like we're exerting more pressure on our
On
hands.
Okay, let's not talk about pressure. Like in a physics class, if you want to talk about pressure, we should define that first. That will not do now. Basically, when two surfaces are barely touching each other, the normal force, the pushing force will be less. The force with which they are pushing or pressing each other is less. But when you press them hard against each other, they are pushing each other with a greater force. What is that pushing force called? Normal reaction or normal force. One of you tell me, in the first case, like on the first 10 kg block, how much is the normal force from the ground?
100 Newtons, sir.
100 Newton. Its weight has to be balanced by normal force. It will be 100 Newton. On the second block, how much is the normal force from the ground? 200 Newton, 20 kg block. Okay. So in that case, normal force will be 200 Newton. No other force is acting vertically, normal and weight. So normal has to balance the weight. That is what is making it difficult to slide the block in the second case. One of you said mass. Mass directly is not the factor. Due to heavier mass, the second block has heavier weight. Okay, due to more mass, it has more weight that generates more normal force. That is what makes it difficult to slide that block compared to the first block. Pawan, are you convinced with this or not? Because you said mass. So do you still think it is mass, or do you think it is the normal force?
The normal force.
Normal force. Okay, you can justify that answer this way also. Listen, all of you. Suppose there is a vertical wall. Okay, wall, just a wall vertically like this. You take that 20 kg block, just make it touch the wall, just put it against the wall like this. Okay, just put it there and leave. Its mass is still 20 kg. But will it be able to stay there, or will it fall down? Like, we placed it there and left it. We are not pressing it against the wall. We just make it touch the wall and leave. Will it stay there, or will it fall down?
It will fall down, sir.
It will fall down, we know from everyday experience, right? And not just 20 kg, you place 200 kg, 2000 kg also if you want, you leave it, it will fall down. Okay. So this shows that it is not mass that influences limiting friction. Okay. It is how hard the surfaces press against each other. This same 20 kg, if you push it like this and press it against the wall, then it may not fall down. There is a possibility. Okay. Like, you can visualize something like this. Suppose this is the wall, palm. Okay. This mobile phone, if I simply leave it here, it will fall off. But if I press it against my palm, okay, against a vertical surface, basically what this pressing force is doing is, it is making the phone press harder against the wall. It is increasing the normal force between them. And if the normal force between them increases, limiting friction between them must have been increasing. That is why the phone is not falling down now. When I press it against my palm like this, it won't fall down. But when I remove this force, it will fall off. Okay. So it's not mass. It is the force with which the surfaces press against each other. So limiting friction depends on normal force between the surfaces in contact also. Okay. So in your syllabus, these are the two factors that you need to consider. Nature of surfaces in contact was the first factor. Normal force between the surfaces is the second factor. On these two factors, it depends how much friction can act between the surfaces. Like, the maximum extent up to which it can adjust itself depends on these factors. And we see that the limiting friction is directly proportional to the normal force. Okay. Harder the surfaces press against each other, harder it will be to make them slide against each other. Okay. So greater the normal force between two surfaces, greater the limiting friction between them. And there's another factor, no, nature of surfaces, that you need to consider. So if you put these two factors together, you get this formula. Limiting friction is mu s multiplied with n. Okay, that's the maximum amount of friction that can act between two surfaces. Mu s is a factor which depends on the pair of surfaces in contact. Like rubber and rubber will have one value of mu s. Rubber and wood will have another value of mu s. Okay. Rubber and rock will have some other value of mu s. Wood and glass will have one value of mu s. Okay. Factor which depends on the pair of surfaces in contact. It's called coefficient of static friction. Okay, in most questions, they will give you the value. Okay, because it has to be found from research only. Okay, mu s value. They'll give you that value. Otherwise, in some questions, they'll ask you to calculate. They'll give you other hints to find out limiting friction and normal force. From that, you can calculate the coefficient of static friction between two surfaces. Okay, so they can ask you questions both ways. But you know that limiting friction, like you understand that limiting friction depends on nature of surfaces. So mu s, that value will depend on the nature of surfaces. Okay, it's called coefficient of static friction. And n is the normal force between the surfaces that you understand. Okay. We'll stop it here for today. So today's class was only meant to give you an understanding of friction. So till now, we had only been considering these forces: weight, normal force, tension. From now onwards, we'll take rough surfaces which can exert friction on each other. And again, we'll have to find out accelerations and all such things. So any doubts in what we discussed today? So tell me, does friction always prevent motion? Yes or no?
No, sir.
It's a clear no, because many times you see motion happening due to friction. Okay, walking is the best example. Friction can help you stop motion in some cases, but it doesn't always stop motion. What does friction always try to prevent?
Sliding.
Sliding between surfaces in contact. Okay, it tries its best to do that. It won't always succeed because it has limits. Okay, fine. Thank you all. We'll continue on what day is today? Friday. Okay, we'll continue on Monday. And I'll send you a worksheet. You have to get comfortable with drawing forces, free body diagrams, resolving weight into components along the incline perpendicular to the incline. Okay, from the forces, telling how much is the acceleration of the object. You should get comfortable with such things. Okay, right. Thank you all. We'll close this session here. We'll continue on Monday.
Thank you, sir.
Thank you, sir.